In this video, you'll discover how to become an NMAP Master in 2025, unlocking advanced techniques and strategies to enhance your skills. Many users struggle with understanding NMAP's full potential and often miss out on crucial features that can elevate their network scanning and security assessments. In this video, we'll explore various NMAP functionalities, from basic to advanced, from step by step. At first, we start from a very basic scan. NMAP and host address, which is very basic command. The command nmap and host address scans the specified host, IP address or domain name, for open ports and gives you a basic information. Let's see the PN flag on nmap. The PN flag skips host discovery, treats all hosts as up, useful for scanning networks that block ping probes. Let's see the SN flag on nmap. The SN flag performs host discovery only with ping scan, no port scanning, returns a list of hosts that are up. Let's combine this scan with our flag for IP range scan. This command performs a host discovery, ping scan, on host while resolving DNS names, even for IPs. It tells you which hosts are online without scanning for open ports. Let's check the PS flag. The PS flag sends TCP SYN packets to specified ports to detect if host is alive. Let's check the PA flag. The PA flag sends TCP ACK packets to specified ports to check if the host is responding to ACKs, good for bypassing certain firewalls. Let's check the PU flag. The PU flag sends UDP packets to specified ports, default 40125, to check if host is alive, less reliable due to filtering or ICMP rate limiting. Let's check the PY flag. The PY flag sends SCTP init packets to determine if host is up. SCTP is a transport layer protocol like TCP and UDP, used on certain systems. Let's check the PE flag. The PE flag sends ICMP echo request packets, standard ping, to determine if host is up, often blocked by firewalls. Let's check the PO flag. PO flag sends IP packets with no transport layer header. Protocols like 1 for ICMP, 6 for TCP, 17 for UDP, to determine host status. Let's check the PP flag. The PP flag sends ICMP timestamp request messages, can bypass filters blocking echo requests. Let's check the PM flag. The PM flag sends ICMP address mask request messages to determine if a host is up, less common and often unsupported. Let's check the DNS server option. The DNS servers option specify alternate DNS servers for name resolution during scanning, useful in cases of internal networks or slow DNS resolution. Let's check the system DNS option. The System DNS option forces NMAP to use the System DNS resolver, example, /etc/resolve.conf on Linux, instead of its own internal resolver. Let's check the traceroute option. The traceroute option performs traceroute to discover the path packets take to the target. Uses the best method based on scan type in OS. Let's check the SS flag. The SS flag sends SYN packets, like half-open connection. This method is so fast and stealthy. Default for privileged users. Let's check the ST flag. The ST flag uses full TCP connect method via OS socket. Slower and more detectable. Default for unprivileged users. Let's check the SA flag. The SA flag sends ACK packets to determine firewall rules, does not determine port state, used for mapping stateless firewalls. Let's check the SW flag. The SW flag similar to ACK scan but checks for TCP window size differences to infer open or closed ports, rarely reliable. Let's check the SN flag. The SN flag sends TCP packets with no flag set, used to evade firewalls and detect open or closed ports based on RFC behavior. Let's check the SF flag. The SF flag sends FIN flag packets. Open ports should ignore it. Closed ones respond with RST, useful against stateless firewalls. Let's check the SX flag. The SX flag sends packets with FIN, URG, and PSH flags set, lit up like a Christmas tree, used to evade some filters. Let's check the SY flag. The SY flag sends SCTP init chunks to probe SCTP services, alternative to TCP and UDP, used in telecom and certain niche protocols. Let's check the SO flag. The SO flag sends IP packets with different protocol numbers to detect supported IP protocols. Example: ICMP, TCP, GRE. Let's check the scan flag option. The scan flags option sends custom TCP flag combinations. Example: scan flags SYN, FIN, URG. Useful for firewall evasion or testing custom behavior. Let's check the scan flags with custom TCP flag ACK. Let's check the scan flags with custom TCP flag URG. You can also use the custom TCP flags initials, like F for FIN, S for SYN, R for RST, P for PSH, A for ACK, U for URG. Let's check the FMTU flag. The F and MTU flags in NMAP are related to packet fragmentation. These options are often used for evading intrusion detection systems or firewalls by breaking packets into smaller pieces. Let's check the DRND flag. The DRND flag generates random decoy IP addresses along with your real IP to obfuscate the source of the scam. Helps to evade intrusion detection systems. Let's check it through a Wireshark. You see, with the normal scan we are sending a SYN request with our original IP. Let's check it again. Now see on the Wireshark panel for the SYN request. You'll find all of the SYN requests from our machine were gone from our real IP. Now implement the DRND flag with 43 randomly generated IPs, and check. Now see on the Wireshark panel for the SYN request. You'll find all of the SYN requests from our machine were gone from 43 different randomly generated IPs. It is like 43 machines are performing this scan against a single target. Now let's check the proxies option. The proxies flag routes NMAP scans through one or more HTTP or SOCKS 4 or SOCKS 5 proxies, useful for anonymity or bypassing IP-based restrictions. You can use this proxies option with PN, ST, and N flags. where PN flag is for no host discovery scan, ST for TCP connect scan, and N for no DNS resolution scan. Let's check the O flag. The O flag enables operating system detection by analyzing TCP/IP stack behavior, response to probes, and other heuristics. Let's check the SV flag. The SV flag detects service versions by probing open ports with various techniques. Let's check the -P flag. The -P flag specifies ports to scan, can be a single port, and can be a range. And the -P- stands for scanning all 65,535 ports. Let's check the F flag. The F flag scans fewer ports, about 100, using the most commonly used ports for speed. Let's check the R flag with -P. The R flag with -P only scans ports in sequential order rather than randomizing them. Default is randomized. Useful for troubleshooting. Let's check the SC flag. The SC flag runs a default set of NMAP scripting engine scripts targeting common services, same as script equals default. It performs basic information gathering on discovered services, such as banner grabbing, SSL certificate info, HTTP headers, SSH key fingerprints, and more. This option is useful for quick, non-intrusive reconnaissance. C. Here we find the FQDN information of the system. FQDN means fully qualified domain name. Let's check it out. Let's add this domain into our /etc/hosts file and refresh. After entering the IP of this domain, let's enter the domain name. Now we have successfully accessed the domain which is hosted on the machine. Let's check the custom scripts of the NMAP. For that, list out the /usr/share/nmap/scripts directory. Now let's run the sshostkey.nse script. Now let's run the sshroot.nse script. SSH brute force is running now. Let's cancel it using Ctrl+C. Let's update the scripts of NMAP. Oops, run it as root. Now our NMAP script database has been fully updated. Let's check the T flag. The T flag sets timing aggressiveness, T0, paranoid, to T5, insane, affects speed, stealth, and reliability. Less speed means more stealth, Like example, T0, designed for IDS and IPS evasion, waits 5 minutes between probes, rarely used due to extreme slowness. T1, good for scanning through monitored networks without triggering alerts. T2, reduces load on the target and network, waits between packets. Useful on production systems. T3, for default timing, balanced between speed and stealth. T4, for fast scanning on stable and trusted networks. May trigger detection systems. T5, for maximum performance. Sends probes as quickly as possible with minimal weight, likely to trigger IDS and IPS. Let's run some scan with T3 flag on triple verbose mode for the verbosity. The min rate option sets the minimum number of packets per second to send, forces NMAP to scan faster. But remember, min rate range between 1 to 10 is very slow and stealthy, useful for evading IDS and IPS or avoiding detection in monitored networks, and 11 to 100 is still fairly stealthy, good for long engagements or blending with normal traffic. But range between 101 to 1000 is noticeable on active monitoring tools, suitable for internal scans with less concern for stealth, and the range above 1001 is considered as noisy, because it is very aggressive, likely to trigger firewalls, IDS and IPS, and rate limiting mechanisms. The max rate option caps the packet send rate to avoid overloading the network or target. So, this is about the video. Thanks for your patience. Keep patience, keep learning, and keep growing. Because hurriness always give you a half experience, but patience can give you the full.